Similarly, for a side-side-side triangle, that is oblique triangle to be specific, we have 3 steps where we use the law of cosines to find the angle opposite to the longest side, then the law of sines to find either of the remaining 2 acute angles, it's kind of arbitrary which we pick, and find the third angle using 180 degrees. So for this example, we want to solve the triangle where we have side length from A to B is 5, B to C is 8, and A to C is 10. So here our longest side is from A to C. That has length 10, and we'll call that B because it's opposite of the angle B. That means if we want to find capital B, we can start with this formula. B squared equals A squared plus C squared minus 2AC cosine B, and rearrange it so we get the cosine B alone on one side. That is 2AC cosine B is equal to A squared minus B squared plus C squared, or cosine B equals A squared minus B squared plus C squared over 2AC, where we actually know all of the numbers that are going in here, A, B, and C. Those are the side lengths. We're going to call little a the length opposite angle A, so that would be 8, meaning we get 8 squared. Angle B, as we said, is opposite side B, so little b is going to be 10 squared. And then C, because we are opposite angle C, is going to be 5 squared, and this is going to be over 2 times 8 times 5 appropriately. And you multiply that out, we will end up getting that cosine of B is equal to negative 11 over 80. Or, if we want to find B, B is equal to inverse cosine of negative 11 over 80, which here will be an angle that is about 98 degrees. And that's the only one we can get here, because if we're turning down into the third quadrant, we'd get a measure above 180 degrees. Which you can't have in a triangle. Because you got negative angles in there. That'd be a weird triangle. So we don't worry about that. But that is what we have here. And to get our remaining parts, we have to think in terms of the law of sines. Using the same sort of idea as last time, we have sine C over little c is equal to sine B over little b, which I'm going to screw up my notation a little bit here, but I'm running low on space, is the same as saying sine of C is equal to C, little c, 5, times sine of B, which is sine of 98 degrees, divided by B, which is 10. Or in other words, C is equal to inverse sine of that mess, which happens to actually be kind of nice approximately. It's about 30 degrees, using a inverse function in the exact same way we did before, just for sine instead of cosine. And now that we have both of these pieces, we're done with step 1 and 2. We can go on to our final step, which is the easiest step. To get our last angle, which here, since we have C and B, means we need A, we take the total angle measurement, 180 degrees, and subtract from it each of our pieces, 98 and 30, to get that A is equal to, but really approximately going to be 52 degrees. And that's essentially all we do here. That's essentially all we do with this set of things for the law of cosines. The main trouble is recognizing which patterns we want to use and then figuring out how we get our steps around where it is a little bit clunky, but it's a lot of applications of things that we've seen before. Next, we're going to move into section 6.3. We're going to start to see something a little bit new and a little bit different. We're going to reframe the way that we talk about coordinates to look at a thing called the polar coordinate scheme. It's going to be a bit of a shift, but I think it'll be interesting. So we'll see what that looks like next.